Hi, welcome to Chemistry Unit 3, 3.1b on chemical bonds. Today we're talking about the types of bonds, polyatomics, and transition elements. For bonding purposes, elements to the right of the stair-step line, including hydrogen, are considered non-metal. Elements to the left of the stair-step line are considered metal. You have two primary types of bonds: ionic bonds, where electrons are lost and gained between atoms, occur between metals and nonmetals, use the oxidation number and the crisscross method. Covalent bonds are where electrons are shared between atoms, occur between two nonmetals, and you in this class must be given the number of each element to be used. Covalent, remember, are two nonmetals that share electrons. Ionic occurs in perfect, crisscross, and today transition elements, given its oxidation number by a Roman numeral, will bond with a nonmetal, and polyatomics. These are preformed ionic compounds that will bond again with other elements. Covalent examples: if I had 2 carbon and 3 oxygen, I could combine them to be C2O3. 1 nitrogen and 2 oxygen would be NO2, and 3 phosphorus and 1 chlorine would be P3Cl. Perfect ionics are like sodium and chlorine, both with oxidations of 1, positive and negative respectively, would make NaCl. Magnesium and oxygen, magnesium with an oxidation of 2 positive and oxygen with an oxidation of 2 negative, molecularly would form Mg2O2 and empirically would be MgO. Crisscross bonding, remembers, where the oxidations drop down to the opposite element, the partner element. So hydrogen has a 1 positive, oxygen has a 2 negative. Those numbers will crisscross to become the subscripts and make H2O, 2 hydrogen with 1 oxygen. Calcium and chlorine, Ca is a 2 positive, Cl is a 1 negative. Those will crisscross to make CaCl2, 1 calcium combining with 2 chlorine. Polyatomics are ionic compounds that are preformed with unique names and charges, or oxidations. Be sure you have the handout for the next few slides. Polyatomics can and will ionically bond with other compounds and elements. So in the first box on your periodic table, with an oxidation of 1 negative, these are very similar to group 17 on your periodic table. They are acetate, bicarbonate, chlorate, cyanide, hydroxide, nitrate, and nitrite. The formula for each, be sure you fill in the blanks. Acetate is C2H3O2. Bicarbonate is HCO3. Chlorate is ClO3. Cyanide is Cn. Hydroxide is OH. Nitrate is NO3. And nitrite is NO2. In the second box on your polyatomic sheet, you have oxidations of 2 negative. These would be very similar to group 16 on your periodic table. They include carbonate, chromate, peroxide, sulfate, sulfite, and silicate. Chromate has a formula of CO3. Chromate is CrO4. Peroxide is O2. Sulfate is SO4. Sulfite is SO3, and silicate is SiO3. In the final box, you have a variety of polyatomics. The first one, with an oxidation of 3 negative, is phosphate. With an oxidation of 1 positive is ammonium and hydronium. With oxidations of 0 are ammonia and methane. Phosphate has a formula of PO4. Ammonium is NH4. Hydronium is H3O. Ammonia is NH3, and methane is CH4. These are examples of polyatomics. If we wanted to combine aluminum and sulfate, aluminum has an oxidation of 3 positive. Sulfate, which is SO4, has an oxidation of 2 negative. When we combine them, those oxidations will crisscross. Be very careful to keep your polyatomic in parentheses as to keep it together. Remember that ratios would mean this substance has 2 aluminum, 3 sulfur, and 12 oxygen atoms. Potassium and nitrate would go together to make KNO3. And ammonium and chlorine would go together to make NH4Cl. Ammonium and nitrate, because a polyatomic can bond to itself, another polyatomic, would make NH4NO3. Your transition elements get their names because they have variable oxidation numbers. However, their oxidation numbers are always positive, and you will be given the transition's oxidation with a Roman numeral. Transition elements are on the metal side of the stairstep, so they will bond ionically with other nonmetals. If I wanted to combine copper 1 and oxygen, copper 1 is Cu1 positive, oxygen is 2 negative. They will crisscross to make Cu2O. Iron 3 and chlorine, iron Fe is a 3 positive, chlorine Cl is a 1 negative. Again, they would crisscross to make FeCl3. Thanks for watching.